Imagine waking up, reaching for your phone before you're even fully conscious, and opening the same 3 apps in the same order. You think you decided to do that, but a lot of that behavior is being quietly scripted by a chemical teaching signal in your brain: dopamine. Modern neuroscience has overturned the old myth of dopamine as a simple pleasure molecule. Instead, it acts more like a silent coder, constantly tweaking your internal algorithms for what you pursue, what you ignore, and what you avoid, minute by minute, day after day. Research over the last 2 decades shows that dopamine is less about feeling good and more about wanting, sharpening your motivation toward certain cues, even when you don't actually enjoy the thing as much as you expect. The real twist is how dopamine teaches you. Many dopamine neurons don't just fire when something feels nice. They fire when reality is better, or worse, than your brain predicted. Neuroscientists call this a reward prediction error, the difference between what you expected and what you actually got. When the surprise is positive, you get a dopamine spike. When reality disappoints, dopamine dips below baseline. That tiny calculation is used by your brain to rewrite its internal rules, strengthening some connections and weakening others. Recent reviews show that these prediction error signals are far more nuanced than we thought, encoding not just good versus bad, but subtle differences in timing, uncertainty, and even your beliefs about what's going on. Now translate that into your everyday habits. Each time you check your notifications, your brain runs a micro-experiment. Is there something interesting? If the answer is yes, a message, a like, a spike of novelty, dopamine pulses, updating the code, this behavior pays off. Do it again. Over time, your brain learns to respond not just to the reward itself but to the cue that predicts it. The buzz in your pocket, the red on an app icon, even the time of day. Studies in animals and humans show that dopamine neurons often fire more strongly to the predictive cue than to the reward itself, pushing you to act before you're even fully aware of the urge. That's the loop. Cue action, dopamine updates, stronger urge next time. Here's one of the most surprising discoveries from recent work. Dopamine isn't just about good things. It also fires for neutral and even bad outcomes, as long as there's a mismatch between expectation and reality. In 2025, researchers showed that dopamine in the striatum signals prediction errors even for stimuli that aren't obviously rewarding, acting as a general teaching signal rather than a simple pleasure counter. Other studies demonstrate that dopamine also contributes to learning from aversive events, helping you remember what to avoid next time and wiring in patterns like anxiety-driven avoidance or overreactive fear. So the same chemical that can hook you on social media can also train you to dread certain conversations, situations, or tasks, and to escape them automatically. Another twist: dopamine is obsessed with costs as well as rewards. Your brain doesn't just track, how good will this feel? It tracks, what will it cost me? In effort, time, risk, and even money. Experiments measuring dopamine release in the striatum show that it encodes both the expected benefit and the cost you're willing to pay, integrating them into a single motivational signal. Even stranger, when you pay a high cost to get a reward, the dopamine prediction error can actually grow, strengthening the association and making the outcome feel more meaningful. That might be one reason why we so often fall for the sunk cost illusion. If we've suffered or invested a lot, our brain dopes the experience with extra significance and pushes us to keep going, even when it's irrational. Dopamine is also deeply involved in how much mental effort you're willing to invest. It doesn't only decide whether you'll go to the gym, it helps determine whether you'll sit and wrestle with a hard problem or instantly reach for distraction. Work in cognitive neuroscience suggests that dopamine makes you more sensitive to the benefits of cognitive effort and less sensitive to its internal price tag, encouraging you to stick with demanding tasks. A 2023 to 2024 series of studies found that boosting dopamine availability can change how people set their decision thresholds, sometimes making them take more time and reach more accurate choices, especially when the decision is complex or uncertain. In other words, your willingness to think deeply rather than skim the surface isn't just a matter of willpower. It's partially a matter of neurochemistry. At the same time, the format of dopamine release matters. Neuroscientists distinguish between tonic dopamine, your baseline level, and phasic dopamine, the sharp spikes that follow unexpected outcomes. Phasic bursts stamp in new learning, while the slower tonic level shapes your general level of motivational arousal. If your life is a constant stream of microstimuli, endless scrolling, rapid-fire videos, ultra-processed snacks, you're essentially hammering your phasic system all day. Over time, addiction research suggests that chronic overstimulation can flatten baseline motivation and make natural rewards feel dull, while making cues associated with artificial rewards feel overwhelmingly compelling. That's why a walk in nature can feel strangely empty compared to your feed, unless you actively retrain the loop. Here's a detail that almost sounds like science fiction. Animals and humans with severely reduced dopamine still show pleasure reactions to sweet tastes. They like the reward, but they won't work for it. They won't go get it. This separation between liking and wanting helps explain why you keep chasing things that don't actually make you happy, like checking email one more time late at night, or chasing status approval from people you don't respect. Dopamine doesn't care if the outcome is truly fulfilling. It cares if your brain has tagged it as worth pursuing, based on past prediction errors. The loop reinforces what's been rewarded before, not what is meaningful in a larger sense. Recent data adds yet another layer. Your dopamine loop is shaped by hormones, biology, and context in ways you might never suspect. In 2025, researchers reported that estrogen can modulate dopamine reward prediction errors in the nucleus accumbens, meaning that learning from rewards and the pull of certain cues may shift across the menstrual cycle. Combined with known variations in dopamine-related genes and receptor sensitivity, this suggests that people don't live inside the same dopamine landscape. Some brains are wired to feel stronger pulls toward novelty, risk, or social rewards. Others are tuned toward stability or avoidance. So when you compare yourself to someone who just has more discipline, you may be comparing two different neurochemical ecosystems. So what can you do with this knowledge, beyond feeling slightly alarmed? One powerful step is to redesign the cues and costs in your environment, instead of trying to fight the loop with raw willpower. Because we know that dopamine responds strongly to predictive cues, you can attach those cues to behaviors you want to reinforce. Putting your running shoes in the middle of the room, setting a deep work playlist you only use for focus, or starting your morning with a short, rewarding ritual tied to reading or learning. And because effort can amplify dopamine-based learning, you can intentionally make meaningful activities slightly effortful, like journaling by hand or taking the stairs to your favorite cafe, so your brain tags them as valuable, not cheap throwaways. Finally, see the dopamine loop not as an enemy but as a programmable system. Over the next week, notice one behavior that feels automatic. Maybe it's reaching for your phone, late-night snacking, or endlessly reopening the same app. Instead of judging yourself, try to map the loop. What's the cue? What's the action? What tiny reward or relief follows? Then, tweak just one piece, remove or delay the cue, swap the action, or upgrade the reward to something aligned with your long-term values. By doing this repeatedly, you're not just resisting temptation. You're feeding your brain new prediction errors and letting dopamine lay down a fresh pattern. The hidden loop that once quietly programmed your life can become a tool you consciously shape, and that shift might be the most powerful upgrade you'll ever make.